As you can see, multicollinearity carries some consequences. Maybe they're not that significant, but they're still there and we don't really want to have them. Therefore, we need to know how to detect multicollinearity. So there are a number of rules of thumb. Some of them I mentioned on this slide. So for example, if you look at your first estimation results and you see that your coefficients are statistically insignificant, which means that you have few significant t-ratios, right? So the t-ratios are somewhat lower than 2, but you have a very high r-squared, something higher than 0.8, this might be the case of multicollinearity. Another indicator of multicollinearity is high pairwise correlation coefficients. So if you estimate individual correlation coefficients and you see that the correlation coefficient is very high between your independent variables, something higher than 0.8, this might be another proof that, or another indicator of the presence of multicollinearity in your data set. There are some formal methods to detect multicollinearity, and the first one is based on the axillary regressions. Auxiliary regressions is when we take each independent variable and we regress it on the remaining independent variables and compute the corresponding r-squared. After this, we take this computed r-squared from this auxiliary regression and we compute the f-statistic using the following formula, where n is, as always, is the sample size, k, again, as always, is the number of parameters, and alpha here, this is the significance level that we need to choose ourselves. So we can either choose 5%, 1%, or 10%. And if the computed f statistic, so if the one that we get from this formula exceeds the critical f, the one that we take from the f distribution table, then we say that xi, so the independent variable, is collinear with the other independent variables. However, if the computed f statistic is lower than the critical f statistic, then we say that the independent variable in question is not collinear with the other variables, with the other independent variables. There is another way the results can be interpreted. Instead of computing f statistic for each auxiliary regression, what we can do is we can apply the Klein's rule of thumb. So instead of formally testing all auxiliary r-squared values by using this formula, what we can do is we can take each of this value and compare it with the overall r-squared obtained from the regression of y on all axes. So we still need to run auxiliary regression, but instead of computing the f statistic, we just take the estimated r-squared and we compare it with the overall r-squared, which we get from our main regression of y on all the independent variables. And if it happens that the auxiliary r-squared is higher than the overall r-squared, then we say that the independent variable in question is collinear with the other independent variables. However, if it happens that the auxiliary r-squared is lower than the overall r-squared, then what we do, we conclude that the independent variable in question is not collinear with the other variables.